And if you have a question, go ahead and ask. Otherwise, I'm just going to start reviewing. Okay. So on Tuesday, the thing that I started working on first and foremost was what was new was basically these flow rate questions. Okay. So what I'm going to do is I'm just going to work through some more of these flow rate questions to kind of get started. And then, like I said, if you have questions, just you can ask or just type it into the chat. So if you weren't here on Tuesday, um, the first thing that's kind of new for you guys this semester is just the flow rate questions. So I did a couple of these already, so I'm just going to do some more to kind of get started. Um, and I'll start off with just keeping it simple as a reminder. What we're doing with a flow rate is we're looking for volume over time. Okay. So the volume that over time that they specifically are looking for you to be able to work with is milliliters per hour. Then, after you've kind of worked through that, you're going to also want to know how to go from milliliters per hour to drops per minute. And so we're going to work through a couple different examples of that. All right. So the first one that I'll work through is this right here, where it tells us that we have a patient is to receive 400 milliliters of Ringer's lactate over 5 hours. Okay. And then we just want to know what we would set the infusion rate to. And then they specifically tell you what would we set the infusion rate to in ml per hour. So all we're going to do here is, and believe it or not, this is actually a commonly missed question because students are looking for more things to do, but all they really need to do is just put the volume over the time and then reduce the values. So that's what I'm going to do. We're going to write 400 milliliters, put it over 5 hours, and then we're going to reduce. So I'm going to take 400 and divide it by 5, and I'm going to get an answer of 80 ml per hour. Now, you can use that's kind of like a straightforward type of flow rate question. And then, like I said, we'll go through some of these other ones here in just a minute. If you have a question like this, where it gives you milliliters in minutes, then you might need to convert minutes to hours. So let's look at an example of that. That's down here. So it says that the patient's to receive 500 milliliters in 15 minutes. Well, we don't want minutes, we want hours. So there's a couple things you can do here. You can just know that, 15 minutes is a quarter of an hour. So you can say 500 divided by 0.25 hours, and then get your answer that way. If you don't like dealing with decimals, the alternative way is just, again, converting minutes to hours. So 60 minutes, 1 hour, that cancels out. And then you just take 500 times 60 and then divide it by 15. And then you get some ridiculous number here, but it's 2000 ml per hour. So if it asks you to, like I said, calculate a flow rate, typically what they're looking for is ml per hour. So if they give it to you in minutes, just make sure you convert it to hours. And if they give it to you in hours, just make sure you reduce your number like we did in the previous one. So if it's 250 ml per 2 hours, 250 over 2 is 125 ml per hour. All right. I don't think I had too many examples of this. So I just left this as one example here. I just said that, the question is, if you have a 250 milliliter or 500 milliliter or 400 milliliter IV bag and it's infusing at a certain rate, how long will that infusion last? That's what this question is asking for. And sometimes I'll ask you to calculate hours and minutes. And so I worked through that. I said 250 ml, 100 milliliters per hour, and then it would last about 2.5 hours, okay, or 2 hours and 30 minutes. On Tuesday, I also went through an alternative example and I just said, well, let's say it was 225 milliliters, still infusing at 100 ml per hour. And then it gave us like a weird answer, right? This 2.25, and they want it in hours and minutes. So how do we convert the decimal to minutes if you need to do that? And like I said, I don't think you will. I think it's either going to be a whole hour or at the half hour. But just in case you do, if you don't know that 0.25 is 15 minutes, what you can do is you just take the decimal part of your answer. So the 2 is 2 hours, but the 0.25, you just multiply by 60 minutes, and that would give you the minute answer. So if you are doing this and you want to make sure you're getting the right answer, that's how you do it. So like I said, you can go back to the review on Tuesday where I went through that if you feel like you need that. All right, let's look at some of these drop rate questions. Okay, so I'm gonna do these two gentamicin questions. Actually, I got a couple of them, so let's just work through the three gentamicin questions here. Again, if you have a question, just type it into the chat, let me know, and I'll stop. Raise your hand and let me know, and we'll we'll get your question answered. But if not, then I'm just going to keep doing these reviews. All right. So these questions here are actually a little bit more of a challenging question because that actually has extra information that you don't need in order to solve it. Now, what I mean by that is when you are calculating for what's considered the drop rate, you need two pieces of information. You need to know the flow rate, which is typically in ml per hour, but it could also be in ml per minute. So it just depends how it's written. But a rate, remember, is just volume over time. So you need that piece of information. You also need to know what's called the drop factor. Now, the drop factor is typically going to be given to you. The only time it might not be given to you is if they tell you it's microtubing. Microtubing means that it's 60 drops per ml. And drop factor is a measurement of GTT per ml. So I'm just going to write over here my little note, microtubing is 60 drops per ml. So they might ask you that. I think that's more of like an ATI type question, but if you get asked a question or they don't provide the tubing information, they're probably expecting that you know that it's 60 drops per ml. But otherwise, it should be given to you. When we combine these two pieces of information, we will get our drop rate, which is GTT per minute.
What's up?
So Trump supports fracking, right? So
Is someone saying something? Did you have a question, Deidre?
Oh my gosh, I'm sorry. My son was talking to me. I wasn't muted. I apologize.
That's okay. Just to make sure. Okay. All right. So flow rate, drop factor, drop rate. So what we're going to do is, in order to calculate this flow rate, I need to know two pieces of information. I need to know the flow rate, either in ml per hour or ml per minute, and I need to know the drop factor, drops per milliliter. Drop factor is going to be given to you unless it's a microtubing. Now, in this question, there's actually some extra information, but you don't necessarily know that yet, so let's go through it. So it says we're going to administer gentamicin 75 milligrams in 150 ml, dextrose 5% water over 35 minutes. And then it says every 6 hours. And it gives us a drop factor of 5. And we want to know what is the flow rate. Okay. So what do I need in order to calculate a drop rate? I need to know volume over time. And I need to know the drop factor. I don't need to worry about what type of medication it is. I don't need to worry about the strength of the medication. And I also don't know how often I need to repeat administering the medication. Is that important? Yes, all those things are important. But when it comes to doing math calculations, we need to make sure we are accounting or we need to focus on what we need. And what we need is flow rate, drop factor. So I'm going to take my flow rate, which is 150 ml, over my time, 35 minutes. I'm going to multiply by my drop factor, and it says it's 5. If it doesn't give you the units, it's always drops per ml. We get rid of ml. Before we do any math, we're already in drops per minute. So now all I have to do is multiply across the top, divide by the bottom. So I'm going to take 150 times 5 divided by 35. And I'm going to get a number of 21.42857. So it's just a hodgepodge number. So 21 point, I'm just going to write 428. Okay. And there's more numbers after that. Now, the thing about drops is you can't give someone a partial drop. So you can't give them a half a drop. You can't give them a tenth of a drop. You can only give them a whole drop. So we look at the tenths place. We see that it's a 4. So if it's 4 or fewer, then we would just round that down or leave it at 21 drops per minute. If it was 21.5 something or another, then we would round that up to 22. All right, I just want to read. So, drop any questions, class. Oh, so the microtubing is a default number, like a constant basically. So if they mention the word microtubing, then it's 60 drops per milliliter. But depending on the tubing, you could have any number of things. So you can have 5, 10, 15, 20, 25. The drop factor is going to be different based off of the gauge of the tubing. So that's ultimately what determines what the drop factor is, which is why it should be given to you. So, yeah, good question. So let's look at, so all I did for these next 2 questions is I basically just repeated the same process and it just changed some things. So what did I change? I changed the flow rate, right? Or I changed the flow rate. So instead of it being 150 over 35, this one's 75 ml over 25 minutes. I changed the strength of the medication to 45 milligrams, but that doesn't matter. Okay. I changed when to administer to every 8 hours. Again, doesn't matter. But I did change the drop factor to 10. So that does matter. We need, like I said, 2 pieces of information. Flow rate, 75 ml, 25 minutes. And then the drop factor, 10. And when we do that, we're going to get 30 drops per minute. So I think you're getting the gist of this. And like I said, a lot of this is, even though it's new, or if you saw it like on ATI last semester or something like that, um, the biggest thing is just practicing. These things take time to get good at, and then just working through different practice problems. I've provided you with several that you can go through, even when you see like, or you have some of the answers or most of the answers or all the answers. It's about the process of once you know how to do it, just practice the flow of answering the question because that's ultimately what's going to happen. So the drops are always answered per minute, while flow rates can be per minute or per. So good question. So drop rate is always drops per minute. Yes. Flow rate is always, so if they're asking you flow rate and they don't give you any kind of indication about a drop factor or anything like that, flow rate is always milliliters per hour. Okay. It'll never be milliliters per minute. Okay. The only reason I'm keeping at milliliters per minute is because it was given and I know that my answer is in drops per minute. So like let's say let's just say in this third example, since that's a good example, it tells me 250 ml and then 2 hours. Okay. So I know that when we're looking for a drop rate, I need to convert those hours to minutes to get to my final answer. Okay. So there's two ways to kind of do that. One of the ways that I always like to do is I'll sometimes just reduce this number. So I'll say, okay, well, 250 over 2 is 125 ml per hour, and 1 hour is 60 minutes. So I just kind of account for the conversion just in the thing. Or some people will do 250 ml over 120 minutes, right? Because 2 hours is 120 minutes. That's perfectly fine. Or you can do a conversion factor and convert hours to minutes, but just make sure when you're calculating a drop rate that you're in minutes before you give your final answer. And then we just multiply by the drop factor, which is 15. And then we'll get, I don't think this is an even answer either. So 125 times 15 divided by 60 is 31.25. So again, we can't write 31.25 drops, so we just round that to 31 drops per minute. So like I said, those are the main types of new questions. You're going to do your fluid intake, you're going to do your conversions, your metric to metric, your metric to household, household to metric. One of the big household to metric conversions you're going to do is that fluid intake type question where you take the different volume liquid, typically in ounces or pints or quarts or cups, and then convert it to mLs. Last semester, I had a lot of students that when they did this, they would just take the ounces or find the ounces for everything first, and then take that number, multiply by 30, and then give the ml answer. Okay. They don't specifically tell you to calculate like what unit necessarily. Like they don't say total fluid intake and then is it supposed to be ounces, is it supposed to be milliliters? But from what I understand, you are supposed to know that you're converting it to milliliters. So um, I don't know when you get told that, but that's what I've been told is what they're looking for. All right. So I didn't number any of these, but you can see there's plenty of um, practice type questions through here. Like I said, the biggest thing is the flow rate type questions, and you're really only going to get good at it by practicing it. So just make sure you're practicing those as you're going through. What I'm going to do is I'm just going to scroll. Um, I realize that the mistake I made is I didn't put any numbers here, but if there's anything that you'd like to see work through, like maybe this two-step problem, like I did this one on Tuesday, so maybe I'll just go ahead and work through this one as well. Um, and then, like I said, if you have any other questions, just drop it into the chat. So for this question here, this is considered a two-step problem because what they want you to be able to do is account for the patient's weight. And so step one is they're going to give you the patient's weight, and they're going to give you it in pounds, and they're going to ask you to find a unit of measure or how much to administer based off of a weight-based medication. So you're going to see this a lot this semester, specifically when you get into the pediatric dosages, because again, you want to make sure what you're administering is safe for pediatric patient. So it gives me a couple pieces of information at 2.5 milligrams per kilogram. Now, when you see kilograms in your order, that's a good example that you're going to have to account for the patient's weight, because what that tells you is that the order is going to vary milligram wise depending on how much the patient weighs. So if it's 20-pound patient versus a 70-pound patient, you want to make sure you know how to make those calculations and be very specific and precise, because remember with pediatrics you can give them too much, right? And so too much could be problematic or could even be lethal. And so you want to make sure that you're kind of following those rules. It tells you that this child here weighs 68 pounds, and we have our available of 35 milligrams per 2 ml. Okay. And so the question is, how much would we administer per dose? And then they specifically ask for the mLs. Typically, when you get a medication label and they're asking you how much to administer, it's usually always going to be whatever that quantity is. So if it's 2 ml, or if it's or the ml, or if it's tablets or capsules, that's what you're looking for. So step one is we're going to convert the patient's weight in pounds to kilograms. So I'm just going to take 68 and divide by 2.2, and that will give me 30.9090. So I'm still going to leave it at 30.9. You might be told to go ahead and round that to the nearest whole number. But from what I understand, at least at CCAC, that they want you to round to the nearest tenth for these types of numbers and these types of conversions. So I always try and keep it consistent. In reality, it doesn't change your final answer significantly. And usually it ends up being the same answer anyways, but I would say round to the nearest tenth. Okay. Then we're going to take that 30.9 kilograms and we're going to multiply by that 2.5 milligrams per kilogram body weight. Okay. So what that does is it eliminates kilograms, and then we're left with what you're familiar with, which is just a milligram dosage, which should make sense, right? So I'm going to take 2.5 times 30.9, and I'm going to get 77.25 milligrams. And then you're just going to do what you would typically do to convert or to find mLs, right? Because that's what you're doing. So if you're somebody who likes to do like the ordered over available, my order is the 77.25 milligrams. My available is 35 milligrams. So those cancel out. And then my quantity. Now this is the one, if you do ordered over available, make sure you're paying attention to what that quantity is. Because sometimes it's 5 ml, sometimes it's 1 ml, sometimes it's 2 ml. So just make sure you're paying attention to what that quantity is. It's a commonly missed thing, is that students will just automatically put 1 out of habit, but you got to pay attention to what it is. Okay. So we're going to take that 77.25 times 2, and I get 154.5, and I'm going to divide by 35. And I'm going to get an answer of 4.4142857. So we're just going to round to the nearest tenth. So 4.4 ml. So like I said, that's kind of a bigger question because there's a little bit more steps involved, and that's what they consider like a two-step type problem. The first step is converting pounds to kilograms, and the second step is just solving for the order of the oral-based med that you've done already now, or you did in 110. So basically, they just want to make sure you can combine skills and get that answer. I had a student ask me about this question. So what I'm going to do is I'm actually going to just create a separate question just because I think it'll be good to do. So let's just say I'm going to get the same information here, but instead of the patient being 365, let's just say it's 265. Okay. So if the blood sugar at noon is 265, how much insulin should be administered? We're just going to look at the values. And so for that one, it would be 6 units. So you just got to be able to read the sliding scale. I think most everyone is pretty good with that, but it's good to at least see it again. So that's all I think. So if you want to practice. Now, someone did ask me on Tuesday, like, well, what if it's 400? Like, is it 10 or is it call the doctor? And I said, well, I don't know if the scale is wrong, like, because usually this does say greater than 400. So I would say, like, anything over 401, so 401 and greater would be call the doctor. So if it's at 400, then you would just administer the 10 units. If it's at 401, call the doctor. Um, I went through the Kefsol reconstitution, so I'll go through the ANSEF reconstitution. The when you get to a reconstitution, there's a couple of clues that you're dealing with reconstitution. The first one is it'll ask you, or it'll tell you that the medication needs to be administered intramuscular. And so without knowing anything else, intramuscular means it's an injectable, which means it's going to be measured in milliliters. Okay. The only caveats to things that are injectables that might not be in milliliters might be something like heparin and insulin are measured in units. So instead of mLs, it's units, but those are not reconstitutions, so you won't need to worry about that. Okay. So for this, what we have is the question, it kind of starts off very similar to other types of um, medications that you've already learned about. The difference is when you look at the label, it doesn't tell you the mLs like right off the bat. It just says, okay, this medication is available, and what we have is a 500 milligram, um, equivalent. And so that's not very helpful for when you're looking for mLs and it only tells you 500 milligrams. So that is your clue that you're dealing with a reconstitution question and that you have to look at the you have to look at the label on the side. Okay. So you have to pay attention to the label on the side. So the label on the side tells you that if we're doing intramuscular, we need to add 2 milliliters of sterile water. And what that's going to do is it's going to give us an approximate total volume of 2.2 milliliters. So those are very helpful pieces of information. Definitely something we need to know. But what we're ultimately looking for is this here in the parentheses. That's the concentration of the medication and what you want to be using for your calculation. So that 225 milligrams per milliliter is what you're looking for. I've looked at several examples of reconstitution labels, and you might want to do the same. Just look up, you can do like a search, an online search for different types of reconstitution labels. I haven't come across one that didn't give you the concentration. Okay. However, if there's a time where it doesn't, what you would do is you would take your 500 milligrams, divide by the 2.2 milliliters, and that should give you that 225 milligrams per milliliter. I just want to double check that. So I'm going to take 500 divided by 2.2, and actually you get 227.27 repeating. So you can see that they even do estimates when they give you these things. But what you want to use what's clearly stated on the label. Okay, so that 225 milligrams per milliliter. And then it's just a matter of solving for that. So I'm going to take my, and this is, again, you can use your order over available if that's the process you like to use. So 375 milligrams. So all I did was convert grams to milligrams divided by 225 milligrams, my available, times the 1 ml. Let's cancel. So 375 divided by 225 will give me 1.6 repeating. And so my answer would just be 1.7 ml. Now, I've had this question asked. Usually it's the 110 students ask this when it's their first time. You're not going to see a question like this. You're going to see the order and the available, and then it's going to say, how much would you administer, or what should the patient receive in a dose? Like that's how you're going to see it. You're not going to see like how many milliliters of water do you add? What is the dosage strength after reconstitution? That's just a reminder when you're practicing these things to look at the label so you can see that. So this was pulled from a book. You can even say it was cut and copied from a book, um, and that's where this question came from. So, all right. So, like I said, those are the main things. I mean, like I said, a lot of this is a repeat of 110, but I wanted to like just give you the opportunity to, if you have any questions, this is a perfect time to ask. Um, if you feel pretty good and solid on this, we still have about 20 minutes left, but if you don't have any questions, those are the main things that I wanted to go over today. So just take a look at if you have access to the review in front of you, or if you have other types of questions from other review material and you want to share it with me and I can work through it with you. But if you're otherwise okay, that's pretty much what I wanted to go over with for this review. You're welcome. Oh, yeah, not a problem. It happens.